using long division in the real world. First question, divide 891 by 3. We know that 891 is the dividend and 3 is the divisor. So we start writing the numbers. We can use a draft to help us. So we have 3 times 1 equals 3, 3 times 2 equals 6, 3 times 3 equals 9. So we look at the first digit, which is 8. So now 8 is divisible by 3. We look at the draft, we have 6. So we write 6 down and we write 2 up, because 2 times 3 equals 6. Second step, we multiply 2 times 3 is 6. After that, we subtract. 8 minus 6 is 2. So now we bring down 9. So we have 29. We look for 29. Now we have 3 times 7 equals 21, 3 times 8 equals 24, and 3 times 9 equals 27. So the number just before 29 is 27. So we may use 27. We write 27 here and we write 9 up, because 3 times 9 equals 27. After that we subtract again. 29 minus 27 is 2. After subtraction we bring down. We have 1 to bring down, so we put 1. Now we look for 21 and we have 21 here. So we put 21 and we put 7 up. After putting 7 up we subtract. 21 minus 21 is 0, so we have no remainder. So the quotient will be 297. Remember, if we have 891 divided by 3 equals 297, so 891 is called dividend, 3 is called divisor, and 297 is called the quotient, and we have no remainder. Another example, 785 divided by 5. So we start writing numbers. We write 785 down and we write 5 here. We may use draft to help us. We have table 5, multiples of number 5. We start looking at the first digit, 7. 7 is greater than 5, so we look for 7. Here we have 5. So we write 5 and we write, or we put 1 up. 1 times 5 is 5. After that subtraction, 7 minus 5 is 2. Then we bring down 8. The number is 28. Here we have 28? No, but we have 25. The number just before 28 and divisible by 5 is 25. So we put 25 and we put 5 up. After that subtraction, 28 minus 25 is 3. Now bring down 5. 35, and here we have 35. So we write 35 down and we write 7 up. 35 minus 35 is 0, so we have no remainders, and the quotient will be 157. Now dividing by 2-digit number. 9,982 divided by 46. So we may use draft for the number 46, multiples of number 46. We start looking at the first digit in the dividend, which is 9. 9 divided by 46 doesn't work, so we take 99. We look for 99 here, but we have 92. So we write 92 and we put 2 up. After that we subtract. 9 minus 2 is 7, and 9 minus 9 is 0, we don't put 0. After subtraction we bring down 8. So now we have 78. For the draft we have the number 46, so we put 46 and we put 1 up. Now subtract. 8 minus 6 is 2, 7 minus 4 is 3. After subtraction we can bring down 2. So the number will be 322, and here we have 322, so we put the number down and we put 7 up. Subtract. 322 minus 322 is 0, so the answer will be 217 without any remainders. Now, factorizing number to its prime factors. If you remember, we have a group of numbers called prime numbers. So what are prime numbers? Prime numbers are numbers greater than 1 and they have only 2 factors, 1 and the number itself. So prime numbers like 2, 3, 5, 7, 11, and so on. Numbers divisible by 1 and itself only have 2 factors only. All prime numbers are odd except all the prime numbers are odd except the number 2, because 2 is even number, so 2 is the only even prime number. If you remember, we have group of even numbers like 0, 2, 4, 6, and so on. They are all numbers divisible by 2. And odd numbers like 1, 3, 5, 7, 9, and so on. So all prime numbers are odd except the number 2. The smallest prime number is 2. We start prime numbers from 2, 3, 5, and so on. The only even prime number is also 2. The smallest odd prime number. Odd, so the prime number is 3. 3 is the smallest odd prime number. If we remember, 1 is neither prime nor composed number, because 1 has one factor only. So composed numbers have more than 2 factors. And remember, any number is a factor and a multiple for itself. Now, for prime factorization, we can write any composed number as product of prime numbers. Like, if I ask you to factorize 24 to its prime factors, so we may write 24 equals 6 times 4, and 4 equals 2 times 2, 6 equals 2 times 3. So this is called prime factorization for the number 24. Or we can use 3 times 8. 3 times 8 also equals 24. So we can write that 8 equals 2 times 4 and 4 equals 2 times 2. And we can use another numbers like 2 times 12. 12 equals 3 times 4 and 4 equals 2 times 2. We put prime numbers in circle. So we can say that 24 equals 2 times 2 times 2 times 3. By 3 different ways, 24 is 2 times 2 times 2 times 3. This is called prime factorization. We factorize the number to its prime factors. Finding GCF and LCM using Venn diagram. We want to find GCF and LCM for the numbers 18 and 12. Now we know that 18 is 3 times 6 and 6 is 3 times 2. So first we factorize the two numbers into their prime factors. 12 is 3 times 4 and 4 is 2 times 2. So now 18 is 2 times 3 times 3. 12 is 2 times 2 times 3. 18 equal 2 times 3 times 3. Now to find GCF and LCM, we put two Venn shapes or two ovals intersect each other, and for the common numbers we put them in between at the part of intersection. So we have 2 times 3 here and we have 2 times 3 here. So 2 is repeated and 3 is repeated. So we can write 2 and 3. We write each number once, only once. We write 2 and we write 3. For the number 18, we have a factor 3. So we can put 3 here for 18. 12, we have 2 remaining, so we can put 2 here for 12. So the numbers 2 and 3 are common factors for 18 and 12. Now we have GCF, which is the common numbers. The common numbers here are 2 and 3. So GCF equals 2 times 3, which is 6. So we can say that the greatest common factor of the two numbers 18 and 12 equals 6. Finding LCM, least common multiple. To find LCM, we multiply all the numbers. 3 by 2 by 3 by 2, which is 36. So the least common multiple is 36. Now for 15 and 16, we can factorize and write the common factors here in between. Now, finally, relatively prime numbers. What are relatively prime numbers? They are numbers whose only common factor is 1. If we found that the only common factor is 1, so the numbers are relatively prime. So when we find GCF of two numbers equals 1, so they are called relatively prime. For the numbers 4 and 9, 4 is 2 times 2, 9 is 3 times 3. Here we have no common factors except 1. So in the yellow part we have no numbers, which means that GCF equals 1. So now we can say that 4 and 9 are relatively prime numbers. We want to answer the following questions. The two numbers represented in Venn diagram are what and what? The first oval shape is 10. The first shape, which is blue, we have the numbers 2 and 5. So 2 times 5 is 10. The pink circle is, or the pink oval is 3 times 3, which is 9. So the two numbers represented are 10 and 9. So we write 10 and 9. The common prime factors of the two numbers are, here the prime factors are nothing. We have nothing common in between. So we want to find GCF, greatest common factor. We have nothing in between, so we put 1. So GCF here is 1. If we want to find least common multiple, we multiply all the numbers. 2 times 5 times 3 times 3. Now 2 times 5 is 10. 3 times 3 is 9. So now 10 times 9 is 90. So least common multiple for the two numbers is 90. So we can say that 10 and 9 are relatively prime numbers because their GCF is 1. Some notes. Number 1, the common factor of all numbers is 1. 1 is factor for all numbers. The greatest common factor of any two prime numbers is 1. Any two prime numbers, their only common factor will be 1. And the greatest common factor, will be 1. GCF of two numbers which haven't any prime factors is 1, which are relatively prime numbers. Common multiple of all numbers is 0. So the common factor is 1 and the common multiple is 0. Finally, the least common multiple of any two prime numbers